How is it going, guys? It's Bendegus here from Flowcrest team, and today I will show you the entire process of making an app with Flowcrest. Today I will choose to make a web app, but you can also create Python applications and anything else. I will just show you here how the new features of Flowcrest, for example the browser and IDE extension, have improved the workflow. I am narrating this video because when I recorded the footage I was in a busy area and I wasn't able to speak. Alright, so let's get right into it. Today we are going to build an app that is a basic math problem solver. It will recognize the problem based on the text surrounding it and will be able to solve any math problem that has the same text but different numbers. So how are we going to do it? First, I created these sample problems. These are very simple, actually. I just asked ChatGPT to create me some basic elementary level math problems. So I created 5 of them. Here you can see that we have a number of examples here. Now let's get back into Flowcrest and start building. I already named the project to task solver and I already gave it the user prompt. If you don't know, this user prompt is basically the specific broader description of your project, so your AI agent will be able to get the context. Okay, so let's create our first node here. I will call this JSON because this is going to be a JSON file. It's going to represent a memory, so every data that is changed or every equation that we provide or configure, we will be storing in this JSON file. I'm giving it a basic description so the AI can understand which part of the whole program this JSON will represent. So again, I'm just asking to create this JSON file and all changed data will flow into it and we access the data via it. All right, so what do we need? We also need the inputs, so we will have these example problems that we have already created by ChatGPT that I showed you earlier in the video. So this is basically a schematic example, and here again I'm describing what these are doing. So these are just text files that contain the mathematical problems that are the schematic for this with some example numbers, and after that we can extract the example numbers and assign a variable for each so that we can recreate or reconstruct the problem if the text is the same but the numbers are different. So basically we will train our program via these schematic examples. So here I'm giving it an example of how to interpret what I am saying because I know that it wasn't really clear. So one thing you can always do with AI, you can provide an example and it will understand it much better. So here I gave it a basic problem that I created and I'm defining how I should be able to select the variable so that the AI can understand it. So just an example, every 3 hours, the 3 will be the variable out of this. And we can give the variables a name. For example, here it's 3 hours, so it's time, so basically T. As in time. Alright, let me add the output. So the output from this node will be obviously the training data that basically represents the full text. And we need something in between the JSON and the schematic example that will create this logic behind it. So we will define the variables and I'm once again describing how this part of the application should work. So this part of the app will be responsible for providing the user with an interface where they can select a part of the text as variables. So for example, we load the first text, this math problem, and we will select the numbers inside and give each a name as a variable. And then we list these variables based on name. Obviously, the input for this part of the program will be the training data. Also here I am adding an additional information that I just thought about, that we should actually configure one task at a time and this should be automatically loaded so we don't have to paste it or something like that. It will automatically load. I am telling the AI to create an examples folder and copy the examples from the root to the examples folder, so it's more organized that way. Let's actually move them, not copy. And the output will be the variables. So we take the training data, do some magic, and the variables will come out the other end. Actually, the text will be another output. So we are taking the training data into two parts, the text and the variables. As an example, I am telling this agent to subtract the defined variables from the text, and we are left with a blank text or plain text that's left over when we subtract the variables. And this text will be segmented by the variables. So we have the first segment, which is until the first variable. After the first variable, we have the second segment, and so on. Actually, this text is segmented text. So one beauty of Flowcrest is this, that one idea pops into your mind and you can go back and change it pretty easily. You don't have to search in your already created prompt. You can actually see on the map. Alright, so of course we want to save these data into the JSON memory file. So let me think about how I am going to achieve this, because I still don't have a very mature idea in my head. So let's create a new node. This will be actually a comparing engine or comparator. So this module will be responsible for comparing the text, I'm in the example, to one that is already configured. So we take in one text and we see if we already have it inside the JSON file based on following logic. Okay, so this part is not that clear how it works on the first sight, so I will probably do a visual demonstration for you guys. So basically we are taking the first part of all already configured tests to the first part of the text in question. I'm giving another example here. So after we confirm that the first segment is a match, we can go on to the second segment. And because of a task can have a variable which is multiple digits long and we don't already know how long it will be, we have to iterate. And this is how we compare two texts together, one which is already configured and already segmented, and the other one is not yet segmented. So when does two text match? Two text matches if all of the segments are matched to one part of the other and in order. Alright, so how should we connect this inside the logic? Let me think a little bit. Alright, let me add an output here. So the output will be if it's a match or it's not a match. And the input will be the previously saved text, which comes from the JSON file. Let me actually add another part of the description to the JSON memory. Let me state that each variable is only bound to its task. So that means that we can have different variables called the same if they are at a different math problem. Okay, so we will input this previously configured problem into the comparing engine, and we have the text in question, which we are comparing to the already configured part, which will be the schematic example. So this is used because we don't want to configure the same text twice. And we will just create a node here to skip the question if it's already configured, so it won't appear in the list. And if it's not a match, then we can feed it back into the variable definer. Alright, so the first part looks about done. Let me just check if everything is alright here. We will actually add another node here and call it equation definer, because we forgot to define the equations themselves. So let me go ahead and do that. Okay, so in this module we can define the equations a problem should be solved by. We can add a new result variable, give it a name, and specify the equation which will be used to acquire that output variable. Alright, so the input variables will be the variables from the variable definer, and we will obviously export the equations and put it inside the JSON memory file. Let me reorder this mess so it doesn't really tangle up that much. Obviously the feedback from the comparing engine to the variable definer already messes up the look a little bit, but it's okay. Let me add a little bit of more of a description. I want this whole pipeline to be able to run in one web app, so I don't want to open more and more modules. And let's save the project, and it looks about done. So let's send the project to anti-gravity, and the prompt automatically is generated and copied to the clipboard, and I just have to paste it inside. And here on the top left corner you can already see the Flowcrest folder. So the way this works, actually, this has caused some confusion in the community. We have two files that are output from Flowcrest. We have the tune or JSON format, which will describe the logic of the node complex. And we have the prompt, which is actually a key to understand the tune or JSON file. So the prompt doesn't actually contain the logic. The logic is contained inside the tune or the JSON file. And so the prompt will be used for the AI to actually understand what the logic inside the tune or JSON means. Alright, so let me talk a little bit about the newest feature of Flowcrest, which are the browser and IDE extensions. On the bottom right corner you can see Flowcrest 3001, which means that Flowcrest IDE extension is running at localhost 3001 and it listens. So we can actually configure which localhost it has to listen, and we can also create another one. And on the Flowcrest page we can also set the localhost port that the browser extension will send the data from. So ideally this should be the same, and with this we can save just with one button, and with this we can just send the hot structure to the IDE directly and also copy the prompt to the clipboard. So let me wait and see when it finishes. Alright, so it looks like we are done here. So let's look at the results. Let's get back to the browser. But first, let's run these terminal commands that we are provided with, and let's open localhost. Okay, so it looks nice. Here we can select the problem. We can select the variables and we can name them. But actually we have an issue here. So you can see that on the top left corner, the 3 just jumped back to the first number 3 in the question. And I also noticed that we have a node issue here. So let me copy the console log. It's quite heavy. And also let me describe my error that is happening with the number 3 here. And let's let anti-gravity do its thing. Okay, so we are done. Let me run the server again and let's try again. Okay, we are at the train page and we can select the density problem. Let's select the 7.8 and give it the variable name of M because this is the mass. And let's select the 3 and it's V because it's volume. And here you can already see the next problem we are facing, that we seem to duplicate these numbers here. But let me go ahead and check if this actually works right now and it's just a front-end issue or it is actually a calculation issue also. We can see that density is mass/volume. So let me create that expression and let's save the schema and let's try the solve part. Oh, okay. So this wasn't what I was looking for. We have to select here manually. I want the program to automatically detect this problem, but let's see if the calculation part works. No match found, please check. Okay. So we obviously have a problem. It might be due to that number 3 right there. So let me try again and configure the variables. Let me see what we are getting actually here. Okay, so it looks like we are duplicating. Let's describe that problem to anti-gravity. Let's start with an example because that always works. And let me describe the problem as best as I can. And let's see if anti-gravity can actually understand this. Let me check again. Okay, so density problem is chosen and let me call this variable M, which works perfectly. Then let me call this one V and it is done. So the issue is resolved, it seems, at least. Let me see if the program will actually calculate. Let me select the second one because I think that is the newest problem that we configured. This one shouldn't work this way, but for now, let me just roll with it. And we can see that the calculation is correct. Let me try out the problem with other numbers, with other digits. And the calculation once again works perfectly. Okay, so here we obviously have this problem that we have to manually select the schema. I want it to automatically understand which schema it is using, and so let's create that inside Flowcrest. The best thing is that with these browser extensions, now we can actually change the configuration of the nodes and send only the difference and also the previous and the latest state, so that the AI will focus on only the difference that we are making. So we can actually build on top of it or just change something in the node configuration and send it to the AI, and it will understand that we have changed some parts of the program. Okay, so this solver part, we will define the solver part right now. So this module uses the previously defined rules and matchmaking to identify if a problem is already defined, and if so, it will solve according to the defined rules. So we are basically taking the logic from the comparator and applying it here to check if the schema is already in the memory for a new task. And if it is, then we automatically select that schema and we will apply it, so we don't have to manually select the schema. Once again, I'm defining that I don't want that drop-down menu. And how should I call this input? The actual question that we are asking here. Let's call it unidentified question. Let's add a new node. And actually this one will be the unidentified question. I just messed up the logic there. Let's describe this one. So this is the question the user just wants to solve based on the previously configured schema. And let me connect the previously saved problems to the solver part, because we are solving based on the previously configured problems. And let me send the diff and just paste this prompt that is automatically generated. Changes are requested, previous, latest, and difference. So we told the AI which files to look at to understand the changes. And once again, we are done. So let's see what we created here. All right, so we select this problem, we define the variable, and we save the schema successfully, and see that we only have an input field here. So that's good. And it matches the problem perfectly and also calculates it. Let me try with different numbers, and it works perfectly. All right, so let's delete the memory part to start with an empty one. And let's see the use case here. We select the density problem. Once again, we define the variables. I know it's a little boring by now, but bear with me. Let me define the equation once again and save the schema. And let's select another schema. Okay, so this is just one bug here that it thinks that it's the same problem again, but we just delete those and let's define the new ones. And let's define the formula here. All right, and now let's try and solve these problems. I will copy over this one, and it once again correctly identifies the schema and also solves the problem. Let's try one that we didn't define, and it perfectly shows that no matches are found. So at this state, we can say that our app is working pretty correctly. So I will consider this project done.
Join the Flowcrest community, because soon the question won't be why Flowcrest, but was there really a time before it?